Example 3.11 is going to show us how to find a antiderivative using integration by parts, and then using that antiderivative to evaluate the area under a curve between 2 points. So here we have a function x times e to the minus x. And we want to find the area underneath this function between 0 and 4. All the way to here. So we find areas underneath functions by taking antiderivatives, x e to the minus x, and we want that x value to travel between 0 and 4. Okay, so this screams integration by parts. We are going to choose to differentiate the x value, and we will integrate e to the minus x with respect to x, and recover minus e to the minus x. So integration by parts says that this integral is equal to uv minus integral v du. Now, we employed one iteration of integration by parts, and this was a definite integral. So this part that came out of the integral needs to be evaluated between 0 and 4. That is part of the antiderivative. Here, we still have something inside of an integral. It needs to be evaluated between 0 and 4. So we're not quite done yet. We are done with that part, but now this part needs to be integrated. So I will copy everything down, minus x e to the minus x, which needs to be evaluated between 0 and 4, and plus the integral of e to the minus x is going to be minus e to the minus x, which, because we just integrated it, now this antiderivative needs to be evaluated between 0 and 4. So main idea here is whenever you employ integration by parts and you obtain something that comes out of the integral, it's a part of the antiderivative and needs to be evaluated between the bounds. So plugging in 4 into the upper bound. So you can rewrite this if you want to as minus x e to the minus x minus e to the minus x, just as a whole function, and run that from 0 to 4. When you do this, you get minus 4 e to the minus 4 minus e to the minus 4 with a plus 1. We can combine some terms and simplify. This becomes minus 5 e to the minus 4 plus 1, which is a perfect answer, and we can approximate this to get about 0.91.